interview with Gordon L. Cuzner, Cuzner, 751 10th Street East, Lot 319, Palmetto, Florida. Phone 813-722-9132, Thursday, February the 23rd, 1989, at his home in Palmetto, with Helen Earley of the Oldsmobile History Center. Tape 1 of 1 tape.
Want my address here
Sure.
or up in Florida or up in Michigan?
No, you can give me your address here,
I'm Gordon Cuzner. My address is 751 10th Street East, Lot 319, Palmetto, Florida.
Okay, now when did you hire in an Oldsmobile?
I hired there January the 3rd, 1934.
Where was the employment office then?
The employment office was in Building 60 at that time.
Building 60?
In the basement downstairs. Mr. Miller was run the employment office or department at that time.
Okay.
I forget what his first name was, but Mr. Miller was the man.
So what did you do when you were first hired?
Well, I went in there as a machine operator in the axle plant. Worked for 46 cents an hour.
What building was that in?
And the axle plant was in Building 36, I think.
Okay.
Building 36, yeah. I started in there working the machine.
Who was your supervisor?
At that time, I cannot tell you. I don't remember that.
You know the superintendent's name?
Yeah, Riley. Mr. Riley was his name.
Okay.
And he's the one that got me a job in the...
This is an oral history interview with Gordon L. Cuzner, Cuzner, 751 10th Street East, Lot 319, Palmetto, Florida. Phone 813-722-9132. Thursday, February the 23rd, at his home in Palmetto, with Helen Earley of the Oldsmobile History Center. Tape 1 of 1 tape. In the machine shop.
I run a spot-facing drill press.
What does that do?
Well, that was, we made steering arms. Front-end steering arms. That's...
Spot-facing drill press.
Uh-huh. Well, it's raining now.
It's coming down, isn't it?
Yeah.
You need it.
Yeah, I worked there in the machine shop for about a year.
Do you remember the names of some people you worked with?
Not at the machine shop, I don't. I wasn't there long enough, I guess, to get too well acquainted. And I went to the metallurgical lab, Mr. Frank Nethaway, and they were looking for some more people. In 34, we were just coming out of the Depression, and I got a job there. And I started in as a metallurgical physicist, and then I got to be...
What were you earning then? What were you making?
Well, by that time it got up to about 90 cents an hour, and I was an hourly employee until after the war.
What building was that?
In Building 40,
Building
upstairs.
40. Okay.
That's where the metallurgical laboratory was. And eventually I got almost to have charge of that complete lab.
What did they do in the metallurgical
Well,
lab?
we tested all of the incoming material that went into the car. And eventually it got to my job where I was going to either accept or reject the material that we buy from various vendors. I would either accept it or reject it.
No,
So,
you mean you tested all of the material, all of the
everything
steel?
that went with nuts and bolts and
Oh.
steel and forgings and castings and
Brass?
everything. No
brass.
No non-ferrous. All ferrous material.
All ferrous materials.
Steel. Yeah.
How did you test it?
Oh, we had different we microscopically with high magnification photographs. We had hardness machines, chemical analysis, tensile tests and impact tests, everything that we ran in there.
How many people worked in the metallurgical
At one
lab?
time we had, well, when I first started there was only 7 of us. And then eventually we got bigger and bigger, and we got so that we had all of the chemical department and the plating departments under us, and the paint and everything else. So we were process engineering department. We had control of all processes in Oldsmobile. Everything that was processed, we did it. And that's about it.
How many were in the department then?
Well, when I left there, I suppose they must have had, we must have had 15, 20 people in the laboratory. Another thing we used to do is they used to, anything that would fail on a car that was sent to our engineering department, they would send over to the metallurgical lab, and we would make our analysis and determine the cause of failure. And then we would report back to engineering, and they would make adjustments in the design or the material that went into a certain part, so that if a part failed, we would first test it for physical properties, that is hardness and things like that, and also the microscopic build-up of the material, and the chemical analysis to make sure that it conformed to all of the specifications that was produced by the engineering department. And then so we worked very closely with the engineering department on, especially on failures.
Now, do you remember any specific failure? Does it come to your mind?
Oh yeah, we had one great failure. One time in the laboratory, we used to send out 2 fellows that would go out into the plant and pick up the parts that were being assembled, take them right from the worker's hand and say, we want these, we're going to test them.
Now, what parts were those?
Well, those were all of the steering gear parts, the rear axle parts, the anything mechanical parts that we take, piston pins, king pins, everything that went into the car material-wise, and especially those that we processed there, that we manufactured at Oldsmobile. I'd send 2 fellows out every Friday, and we'd pick up these samples, and then we'd check them and to find out if they were according to specification and if the right material was going into the right place. Well, one day we went out and we picked up 2 steering knuckles, and when we got them back to the lab, we found out that they had not been heat treated. Well, this immediately started a terrible, vicious, rapid campaign in General Motors. We put cars on a proving ground with unheat treated steering knuckles, and we at that time we just got into ultrasonic testing so that we could use this ultrasonic to put it on the steering knuckle and tell whether it had been heat treated or not. We sent people to, in those days we boxed up cars to send them overseas. We sent men to New York on the docks to tear those boxes open to get into those knuckles, and we...
What year was that?
Well, I can't... Well, it must have been in the late 40s, I would say.
After the rocket engine came out?
Yes, oh yes, And we, well, I kind of lost my train of thought, but anyway, we were sending, there was assembly plants all over the United States, and we sent these front end assemblies. These were the spring supports that went out for the front wheels, and they were sent out in boxcars all over the country. And we got all of those boxcars back, disassembled every one of those parts in there, and tested them ultrasonically to see if there was any that was non-heat treated.
Tested the steering knuckle.
Yeah, the steering knuckle. We had an ultrasonic sensor that we could place onto this knuckle, and it would come back and make on a screen. It would tell us whether the part had been heat treated or not.
Well, now, was that steering knuckle a part that Oldsmobile had made?
Oh yes.
Well, how could it have gotten into use?
It got there. Well, that was one of the problems. But anyway, in the Ford's plant 2, over in Saginaw Street, where they made these steering knuckles, nearest we could come up with was that a truck driver had got a gun full of these steering knuckles and put them into a place where they got machined and went into the car. And we figured out, we knew how many knuckles there would be in a gun. There was several hundred. And if this was true, if our thinking was true, then we did recover all of the unheat-treated knuckles, and they never went into cars. But the whole corporation was terribly upset because we thought we had a lot of death traps in automobiles, because these are the things that the wheels spin on. The steering knuckles are what the front wheels spin on.
What would happen if a knuckle that hadn't been heat-treated went in a car, steering knuckle?
We thought that they would fail, that they'd be overstressed and they'd fail, but a proving ground check showed us that we had no danger whatsoever. They did stand up, which brought up a question: why heat treat them and the heat treating is a very expensive operation.
I see. So after that, did they just continue heat treating the knuckles?
Oh no, we still heat treated. Oh yes. Yeah.
How would they, at the proving ground, how would they test a
They
car?
put them on a test track, the Belgian block test track,
Mm-hmm.
and they just beat the devil out of them. But we couldn't. They did not fail. So
Was that done manually? A person was doing it
oh yeah,
himself?
at the proving ground they have a Belgian block road that's got high and low
Blocks.
lots of blocks in it, bumps and everything. They just drive them over there just as fast as they can, over and over and over, see if they would fail. See.
I see.
See, really, the reason a part fails is because it's overstressed. And then that comes into design, which goes back to the engineering department, who will redesign a part if it's found to be overstressed. It's like bending a piece of steel or something like this until it finally breaks. That's stressing, that's overstressing, and that's why a piece of metal will fail. And that was one of the biggest things we had. That went on for weeks and weeks and weeks, and we were still figured we didn't know how many cars we might have had on the road that were in bad shape. But as it come out and everything worked out, everything was all right. So we didn't have any big lawsuits. Lots of times we would have to. I never directly got into lawsuits, but we, General Motors and Oldsmobile, would be sued by various people, and our test results will be taken to court to show that the material in that particular failed part was to our specifications. We had a lot of lawsuits. Not a lot, but several.
Do you remember any lawsuits?
No, I never was involved in it. Just my work was involved in it. They never had me in court or anything. But my bosses, Andy Hoover, went to court on one or two of the trials.
Do you remember either one of those specifically, what the part was?
No, for the life of me, I can't remember what that is. But yeah, that was a big deal with the steering knuckles. That's the worst job I believe I was ever in. And it was weather just like this. It was bitter cold. And we went over and I can't remember the name of the building, the number of the building over by Logan Street Bridge, right by the bridge and the railroad track. But anyway, that's where they shipped all of these parts out. And that's where they brought them back. And it was open at one end and everything. We was right out in the cold in the middle of January or February, and it was bitter cold. We had to work on it, and we did it, and we think we found all of the parts that were not heat treated.
Could you test the part right in the car?
Yes, with this ultrasonic test. This came in. This is something new. Had just come in, and I went to Chicago to go through a course on this ultrasonic testing. This means that you could put a sensor on one end of a bar of steel and another sensor on the other and shoot this sound wave through this bar of steel, and if there was something wrong with it, it would show on the screen. See, a pip would show. So we eventually went into testing all of our bar stock steel, like bar stock to make axle shafts, crankshafts, and stuff like that. We tested all of those with ultrasonics, and see, when Oldsmobile went into the steel making plant business, then we were making our steel from our scrap and making it into bars so that you could make axle shafts out of it, forge them, and knuckles and stuff like that. Then these bars were all tested before they went to the machine, so we know we had good material. See, when you make a bar of steel, when you roll it out, you can make chevrons inside of this steel that are not visible from the outside, but they are a void inside of this steel. Well, ultrasonic will pick that up, and you throw it out as scraps, and then you remelt it and make it over again.
I see. Was that part of the scrap utilization program?
Yes, ma'am. That was part of the
When did that go in? Do you remember the year?
No, gosh, I don't. I say, oh, golly, I don't know. I'd say we went into that in the early 50s. Yeah, and see, then we went into the gear making business over in Plant 2, where we made all of the ring gears, side gears, and pinions, drive pinions, and everything else over there in Plant 2. So at that time, the building was just being renovated, and I had to buy, actually I was involved in buying all of the heat treating equipment for that job, which we went all over the country to look at equipment and everything. We bought about $10 million worth of heat treating equipment just to start this plant in operation.
Well, now, was that all under the metallurgical lab?
It was all under the metallurgical lab.
I see. Who was the superintendent there?
Lloyd Pierce was superintendent. At first, when I first went there, Frank Nethaway was the superintendent. And there was Frank Nethaway and Mr. Crawford and Mr. McDowell. Mr. Crawford was a metallurgist and McDowell was a chief chemist. And Nethaway was a chief process engineer. And so we had two divisions in the laboratory. One was metallurgical and the other was chemical. And then we got into plating. All the bumpers and everything were plated. And I helped set up the plant over in, I can't think of the name of it, the old axle plant. Anyway, we put a plating plant in there. And
Plant 3?
No, it wasn't. No, Plant 3, they eventually transferred all of that over to Plant 3, but before that, it was in the main plant.
I see.
And I can't remember what building that was. I could, if I had a map, I have another plan,
Sure.
I could tell you.
Well, now, this $10 million worth of heat treating equipment went into Plant 2.
Plant 2, yes.
And can you describe the method, the process of heat treating?
Well, yes, it was a carburizing treatment where you machined the part, the gear, and then you had to carburize it. That is, you put it into a furnace and in an atmosphere, which we had to prepare this atmosphere that was high in carbon. And if you took the part up to about 1650 degrees, it would absorb the carbon in the atmosphere into the steel and make a layer. It's called case hardening. And it puts a case on the outside of that gear, so that it makes it very, very hard for wearing and running in the car. And we had to carburize. Now it would take the part would have to be in the furnace for 1650 degrees for 8 hours. Then it was drawn out of the furnace and directly went into a quenching machine where it quenched it and cooled it down and pressed it at the same time so that it didn't move while it was being quenched. And then it became very, very, very hard. And about as hard as glass, Rockwell C63 or 64 or something like that. And then we had to stress relieve it because it was too hard and too brittle, so we had to put it back in the furnace at a rather low temperature of 300 or 400 degrees, which would relieve the stresses due to the violent quenching action that was set up in the surface of the steel. And then that's what you call tempering. And we would temper the steel, and then it would be suitable for usage in the car.
How many hours would it be tempered then?
All we had to do was take it up to temperature. So I would say it might be about a 2-hour cycle. Something like that.
Now, what was this quenching base?
That was oil.
Oil.
That's a quenching oil, huh? And you had in the gears you had a very special machine. It was very expensive, and the hot gear at 1650 was placed into this machine and then pressed, and then the oil, it was flooded with oil, and the oil had to be controlled at a certain temperature at about 100 degrees, and it's very smoky and dirty and very important operation. This really that's a heat treating operation where you heat it up to a certain temperature and then quench it and then temper it. There you have a complete heat treating operation.
Well, how many tons of material did you...
I couldn't tell you the number of tons of material. See, we used to make all of the piston pins, and way back when we used to have king pins. We used to make all of the king pins. They were all carburized, and they would be... See, this 8-cylinder car, you would have 8 pistons, 8 pins. You would have 2 king pins for each car. So for every car we made that, I don't know.
Now, carburizing, what does that mean?
Carburizing is increasing the carbon content of the surface of a hot piece of steel.
Now, exactly how would you do that?
We put it in a temperature in the furnace at 1650.
You put what piece in?
Well, let's say it was a ring gear. This goes in the rear end of your car. They used to drive the axle shaft. We take the ring gear and we'd place it into a rack, and there'd be several of these ring gears in this rack or box. And the rack had to be very, very special steel, very expensive, high nickel content. And we'd push it in there into the furnace on a conveyor, and it would load the furnace. There'd be about 4 or 5 or 6 of these racks in a row, and it would push cycle it. So we had it timed so that these racks would stay into the furnace 8 hours and come out the other end. Now, when this thing went in, it went into the furnace, and the furnace was, the atmosphere was prepared. We had what we called gas generators. This is all very dangerous stuff, and it would be violent if it ever got out of hand. And we had a gas generator, and we'd mix it so that it was high. It had not burned up all of the gas that was in it, because gas is full of carbon, see. Now, when the steel gets up to 1650, it begins to absorb this carbon in the atmosphere, very smoky and very dirty, and it's absorbed in the surface of the steel. And that if it's in there for about 8 hours, we'd like to have about 50 thousandths case. This is an outer layer. Case is an outer layer that we're putting on this piece of steel. We're just enclosing this whole piece of steel with a layer of carbon-rich steel.
Okay.
And then with this carbon, see, steel will not harden unless it has enough carbon in it. Carbon is a determining factor as to whether steel will harden. And carbon and iron forms iron carbides. And this then makes this surface on the outside a good wearing hard surface, a carburized case on this surface. And each one of those baskets, we had a sample piece. We'd take it to the lab. We'd make sure that the piece had enough case on it and it was to our specification, or it was rejected. We never took anything that was not right up to our specification. So we always had in each one of these baskets a test sample. and that test sample was picked up, and we didn't care whether it was ever got quenched or not because the carbon would still remain in it. The reason you quench is to make the steel very, very, very hard, awfully hard, and then it's stress relieved. We call it or tempering, and this takes the stresses out because when you violently quench this, you set up stresses inside of this piece of steel, which could make it crack or something. That's why we say a part fails because it was overstressed. The stresses within inside of the steel are just more, they just couldn't stick. It breaks, cracks. So we temper this, and we temper this to let this steel be usable. It wouldn't be usable if it was just quenched, and you couldn't use it. It'd break right up, be chipped.
Oh, these parts then were already cut.
Yes, they'd been machined. Yes.
Machined before they were put in the racks,
and then go into the furnace. Yeah.
Mm-hmm.
These furnaces were huge. Maybe 50, 60, 70 foot long, maybe 12 foot wide, and probably overall the height might be 20 foot. These are huge things, bigger than a house.
Mm-hmm.
As big as one. This would be a small furnace the size of that house that we're talking about.
Oh, yes.
And they're all heated by burners, and we have to control that temperature very, very critically. We have to make sure that the temperature in that furnace is what it's supposed to be, otherwise the parts won't come out right.
Mm.
So periodically, I had a group of men that we would run a long thermocouple. A thermocouple is a piece of two dissimilar wires with ceramics around it, and we put that into one of these baskets and let it go through the furnace and hook it up to a potentiometer, and this would tell us a temperature. So we knew that it took so long to get this part up to 1650, and we knew we'd hold it so long, and then it goes off down. So we tested every once a month. We would run test couples through that furnace to make sure that it was heating, the burners were adjusted right, and the gas mixture was right, and everything else. I had charge of those men that were doing that. And, that's about it.
Well, Gordon, what fuel did you use?
Natural gas.
Natural gas.
Natural gas in here.
I see. And how many pounds could you harden at one time?
Oh, hundreds and hundreds, thousands of pounds at a time.
Several tons.
See, it depends on how you do your heat treating. If you were going to heat treat a bolt, we just feed those in on a conveyor into a moving belt that moves through the furnace. And when it goes through the furnace, when it's been in there long enough and if the speed is just right, it falls off into a big vat of oil, and it's quenched, picked up by an elevator, goes up and goes through a washing machine, and then into the draw furnace, which is a temper furnace, and comes out the other end, and they put them in a gun. It's just a straight line procedure.
Mm-hmm.
That's all.
Well, what would that conveyor be made out of?
Very high nickel steel.
I see.
Castings, steel castings.
Mm-hmm. I see. And what was in the wash after this quenching?
Oh, just ordinary wash compound. I can't tell you any name of any.
I see.
Just to get the oil off. See, we'd wash the oil off. They go oil quench. They drop off this conveyor, come down this conveyor, and drop into this tank, into a tank of oil, which was being agitated, so that we made sure that the heat was taken away, and then it dropped, and then the conveyor takes it right up, and it goes down into the draw furnace, through the wash, and then through the draw furnace.
I see.
Uh-huh. So that was very, very...
well, did you ever have any accidents?
Oh, yes, we had fires, explosions. I partner got my head blown off once. And
How'd that happen?
Oh, we bought a new furnace, and they didn't put it together right, and I was trying to light the thing, and it got filled up with gas, and I had a torch, and it exploded. That was it. Boom. Burnt my face and took my hair off a little bit. Yeah.
Gee whiz.
Oh, yeah, that's when you're dealing with this kind of stuff. You're dealing with very violent material, gases and everything. And everything has to be just right, and you have to know it's right. You have to have instruments that tells you that this atmosphere and this conditions are right. We have all these sensing instruments that would tell us if something isn't right, a little bell will come on or a little light will come on, and we have to hurry around and find out what it is and then make sure it's right. We can blow the place up.
So actually, that's a critical job
Oh,
to
critical.
make
I'll say it's
certain that
critical.
those
Oh,
machines are working all
That's
right.
right.
those
Yeah,
furnaces.
yeah.
Hmm?
Yeah.
Well, eventually these machines would go down. I mean, you
Yes.
wouldn't have that furnace going all the time. How long would it take it to get it up to 1650 degrees?
Oh, usually, see, you work the heat treat on a 3-shift basis, and if we had a Saturday off, we would shut the furnaces down on a Friday night, and then
Okay, we're in business.
the midnight shift would start to light the furnaces up, so when the day shift come on, the furnace would be up to heat. It'd take about 8 hours to get the furnace up to
I
heat.
see.
See, there'd be hundreds of burners on these furnaces on the side of the furnace, and fans on the inside that keeps this atmosphere turning and moving just right, so that the carbon would flow around the parts and the heat would get to them. You had to make sure that every part got up to heat, the temperature. See, in order to harden a cylinder head bolt, you had to get up to 1550 degrees. This is what you call a solid solution. In other words, steel has got carbon, manganese, phosphorus, sulfur, nickel, chrome, and everything else in it. Now, as we bring this temperature up, the iron and the other elements that are in the steel begin to get into a homogeneous condition, so that they're all mixed up in this. This is the only way you can heat treat a part, is by getting it into a solid condition, see. Solid solution, we call it, so that all of the elements in this particular steel. Now, you buy steel by certain designations. Some of it can be a carbon steel, some would be nickel steel, some would be stainless steel, some would be a chromium steel, and we had to buy that material. That, in other words, if we wanted to make it a cylinder head bolt, we had two choices. We even made it out 1335 or 3535, and this meant that we had, it would be a plain steel with only a little carbon in it. 1335 or 1035 would be plain iron with 35 carbon. Now, steel will not harden if it's somewhat less than 35. If it's around 20, you get 1020 steel, that will not harden no matter what you do to it, unless you case harden it. Then we can case harden it and increase the carbon on the outside of the steel, and then it will harden. And that's what you do with, say, a piston pin, for instance. Piston pin was made out of 1016 steel. That meant that it was just iron and carbon, but very low carbon. And that made the core very tough, but soft. But we would carburize it, and we'd make the surface very, very, very hard. And so you had, in a piece of steel that was carburized, the core will be reasonably soft, the surface will be very, very hard, and very high wearing. This is all very interesting, but that's the way
it is.
You have to know all of these things, and then you have to know how to do it, and you have to know what to do when things go wrong.
Can you think of any instance?
I've had lots of times where purchasing would call me up and say, "Hey, Gordy, we got to have some 1335 bolts, 1335 steel bolts." He says, "The only thing I can get is 3135. Can I take it?" I tell him, "Sure. We're getting a lot more for our money, see." But if he went the other way, if he says, "We got to have 3135 and I'm going to get 1035, no, doesn't have the strength. And so it can't go into that particular part in that place.
I see.
See, in an automobile is put together by stresses. What holds it together is the ability of this material to take the punishment that it's going to get under the conditions it's going to operate. So you have to, and then you have to plan ahead. It's going to be treated a heck of a lot worse than it really is, because most people don't take care of what they're supposed to do. So you have to anticipate these overshots and things. So we would use we take lots of material went into Oldsmobile that was better than it was supposed to be, but that's all we could get at the time. See, you'd buy your bolts from a bolt manufacturer. They made the bolts, and then we'd buy it and get them, and then we'd heat treat them, because it was cheaper for us to heat treat them than to let them heat treat. So we were making money that way. And when we did our heat treating, and they'd make the part, they'd make the bolt, and then we would do the heat treating. Then we made money on that, quite a lot. If we bought the bolts heat treated, it cost you about 35 cents a pound, and we could do it for about 6. So we were making a lot of money. See, there's hundreds and hundreds of bolts that go into an automobile and keep it together. So we made cylinder head bolts, bearing cap bolts, all kinds of bolts.
Remember any incidences where someone was injured working with the heat treating?
Oh, well, working in heat treat, you have to expect you're going to have some fires once in a while. Yeah, somebody will get burned once in a while or something like that. Nothing any serious.
Mm-hmm.
I think what happened to me was the most serious thing that ever happened in the heat treat. But I bought a new furnace, and they'd shipped it in, and they had it all hooked up and everything, but they left one valve open that I didn't know, and I didn't see it. And it was all covered with aluminum paint anyway. And so I tried to turn it on, and I had the torch to light the burner, and the vestibule of the furnace filled up with gas, and it just exploded. It blew it all to pieces. Kind of burnt my face a little and my hair, and that's it.
Well, it must have damaged the machine, too.
Oh, yeah, blew the door off. Yeah. Oh, the heat treat, see, we had, in building 35, that's where the main heat treat was. And then downstairs in the tool room, we had a heat treat downstairs in building 40 in the tool room. We had furnaces down there, small ones, about the size of an oven or something like that. But we still had to maintain those under the same conditions, because they were making tools for our machines to do their work.
Oh.
And Ed Kynes down the end of the street used to work down there in the tool room.
What was his name?
Kynes.
Kynes?
Yeah, he was on hourly.
Mm-hmm. I see.
Mm-hmm.
Oh, I wanted to ask you about the steel that goes into the hoods and the fenders.
Uh-huh. That we bought. That come from U.S. Steel or someplace else. But it comes in, you've seen them come in the big coils of steel on the back of the trucks.
Mm-hmm.
I don't know how many hundreds of pounds they weigh, but they're awfully heavy. That makes the fenders and the hoods, and I suppose what goes over the fish's body to make the cars too. That steel, when it come in a coil, we got a sample at the laboratory off in every one of those coils. And we'd make a hardness test, a micro-examination, and a chemical analysis of that steel. And we'd also, we had a machine that would, this steel was put in a press. When it goes through, they have the big dies that come down and makes the fender or something. And this steel has to have the ability to stretch that far to make these curves around your fender and everything. So we had a machine that would tell us whether it had to meet a certain, it was a great big ball bearing, and we forced this into the steel, and it had to go down so far into the steel without rupturing or failing. So every coil of steel that went into an Oldsmobile was tested by the laboratory and approved. The same way with every bolt. Every load gun of bolts that ever come into Oldsmobile had a tag on, do not use. Every morning I would send out a group of men and say, approved these gons, so many gons of bolts. And those that we didn't want, we sent back to the vendor. And they eventually would mix them up in our stock, and we'd probably get them back anyway. But anyway, everything we had, everything that went into an Oldsmobile was tested. And tested right to specification. I'm not so sure whether the specifications were right, because those are engineering. That's engineering's work. But we checked to their specifications, and nothing went into an Oldsmobile unless it was approved by the laboratory.
Mhm.
Nothing.
Who
That's
was,
why you get a good car.
yes.
That's why I got so much confidence in Oldsmobile right now. I know what went into them when I was there.
You bet.
Yeah.
Well, you didn't do anything but brass then.
No brass. No, that's called non-ferrous. It's no non-ferrous.
I see.
All of ours was ferrous metal.
Hmm. Now, what is a ferrous metal?
Ferrous metal is it's iron and carbon,
Mhm.
and the other elements that you want to put in it to make it stainless, or see, it's carbon, manganese, phosphorus, sulfur, silicon, nickel, chrome, molybdenum, titanium, whatever you want to mix in, the type of steels you want to make. Each one of these elements that you put into this steel raises the price. It goes up. See?
Mhm.
The way they make this steel is that they have a big ladle, and they have their scrap iron. They analyze the scrap iron, and then they find out what's in it, and then they make their additions. So if there isn't enough manganese in there, they put some in. If there isn't enough phosphorus in it, they put some in. And that's the way they just dump them in a cart, and they just take them over and dump them on. They'll load a great big cart and dump it in. And then as the steel boils and melts and everything, it gets all mixed up in it.
So the scrap utilization program then was a very good
See,
thing.
a lot of, well, you see, steel that you use for fenders and hoods is what they call low carbon steel. It has practically no carbon. It's pretty near all iron and manganese and stuff like that. But the steel they get from fenders and stuff like that, they would have to add these other elements to it when they're making this steel, these big ladles, and they pour it out, and then they finally, it ends up into ingots, and then the ingots are rolled and cut and shipped and
Is that
descaled.
cold rolled steel?
You get cold rolled steel, yes.
I see.
You get hot rolled steel will have a scale on it. And in order to use it, unless you're going to use it underneath the car, we use a hot rolled steel underneath the car because of the rusting problem. But a cold rolled steel would rust very rapidly, and so it would have to be treated. See, so they have these Bondurite tanks and everything where they Bondurite this steel.
Now, what is bonderizing and how?
Bonderizing,
what's the process?
chemically, I can't give you any formulas or anything for that, but it is a material. It's just a great big tank full of this liquid, and it's called Bondurite. And your steel goes through there, and it gets on the surface of the steel and prevents rusting from underneath the car.
Now, would that be before the steel is cut into shape?
Yes. Uh-huh.
I see.
Uh-huh. A lot of it, you see, then after the fender or the hood is formed, then it would go through a painting tank, a drip tank. It just go hang it on a conveyor and go through there, and it come up, and all the black paint would drip off, and it goes through an oven, and it's all dry. And then it goes to be assembled or be painted any color that they got it. I don't know how they do that, but anyway, all the fenders and the hoods and everything get to some place where they match up, and they got all green ones. Every once in a while, you might get a bad car with a green fender on a red car, you know.
Well, so this first process through the drip tank is sort of a rust proofing?
That's right. Uh-huh.
I see.
Now they're saying, Oldsmobile is saying that we don't have to undercoat our cars because the steel is such that it will not rust.
Mm.
They're advertising that way.
I see. Undercoating is what, $80, $100?
Yeah, they say you don't have to do it anymore.
Mm-hmm.
That's what I hear.
What are some of the people you worked with?
Well, let's see. My immediate boss was Andy Hoover,
Mm-hmm.
and my big boss, Lloyd Pierce,
What kind of a man was he to work with?
Oh, wonderful, marvelous.
Mm-hmm.
He done everything. He treated me like his long lost son, I believe. And I knew everybody. I knew Mr. Rollis. I knew
Did he come out in the plant often?
Mr. Rollis.
Mhm.
Oh, he was in our office all the time.
Mm-hmm. And that was over in plant 2.
Oh no.
Oh, you were in the main plant.
I was in the main plant. Yeah,
In
building 40.
Building 40.
Upstairs in building 40.
Second floor.
Uh-huh.
Okay.
Right in the front end. I built that whole lab up there. I bought every piece of every chair and every clock and everything in that lab. We were down in the center of the building, and then we moved up to the front of the building.
Mm-hmm. Well, what year was that when you moved up there?
Oh boy, I don't know. I'd say in the well, let's see. Must have been in the early 50s somewhere.
Mm-hmm.
Yeah, I worked in then Eulo Forsyth. He was a chemist. He's over at Barefoot Bay over on the East Coast.
Mm-hmm.
He was a chemist. I was not, and I worked with Gordon Goodrich. I worked with Earl Ellis. Oh my, hard to remember some. I've been out there so long. It's hard to remember.
When did you retire,
I
Gordon?
think I retired in '74. I'm not
19?
sure.
Now you were salaried then.
Yes.
When did you leave the hourly to go into salaried rank?
Oh, long. Gee, I can't tell.
Mm-hmm. Okay.
I finally went through all that. I had a company car and everything, so I was doing all right.
You remember what your your starting salary was when you got on salary?
I don't remember what it was, but I remember what I told the boss. He come in and he said, "Boy, I got some good news for you. We're putting you on salary." I found out what it was, and I said, "Hell, I was making more on hourly than I was on salary." But it finally, Mr. Pierce took care of that in a hurry.
Mm-hmm.
Yeah, he treated me wonderful. Bob Rollis, I don't know, you remember him?
Yes.
He was the head man, you know.
Yes.
He and Lloyd Pierce were just like this.
Mm-hmm. Do you remember any special incidents of odd tests that you had to run on certain parts that you had a problem with?
Well, not particularly. It was very interesting work. I really enjoyed it. It was. I don't recall of any special one except this knuckle deal I was telling you about.
Mm-hmm.
That was a catastrophe. The whole company, General Motors, all shook up. We thought we were in awful trouble there. That's the only one that was major.
See. Because Oldsmobile was making knuckles for the other car divisions too?
Well, see, we made most of the knuckles and steering apparatus for Cadillac.
Mm-hmm.
In other words, as far as I'm concerned, a Cadillac's just an overgrown Oldsmobile anyway. It used to be anyway. When I was working there, they made their own motor and everything, but the rest of it, I think Oldsmobile made most of it.
Mm-hmm. What about the aluminum engine? Did you do?
Oh no, I had nothing
to do with that.
Long time ago, I remember. Oh my, this is years and years. When they were fooling around with something with that, but I didn't get into it at all.
Mm-hmm. They didn't.
Then Dave Ording, he went out to the plant out west of town there and
Plant 4?
started working on that quad engine, whatever.
Oh.
Dave Ording, I knew him very well. I know.
Mm-hmm. Well, then you didn't have to test any aluminum for the engine or anything?
Nothing non-ferrous we did not test.
Mm-hmm.
No. See, we had aluminum pistons. I remember we went into aluminum pistons. Before that, we had cast iron pistons. We used to test the cast iron pistons with aluminum. We didn't touch. I don't know why.
That seems strange,
Yeah,
isn't it?
I don't know why, but we didn't. With connecting rods, for instance, now we test those every week. We'd go out and take them. Guy getting ready to put it in the engine, we'd take it right away. This is the one we're going to test. We had to make sure that the rod, connecting rod, that hooks onto the crankshaft and goes onto the piston. It's
crucial part.
Yes, it's one of the very rapidly moving parts, you know. So you have to make sure that's all right. Plus the piston pin that goes in the piston. In through the rod goes up here and the piston pin goes through there. That's very important. That's carburized and hard and extremely hard.
Mm-hmm. Well, now, was there some method of, when, say, a shipment of steel came in that you had to test, that you would know who the supplier was?
Oh,
So
yes.
if there was something
Oh, yeah.
wrong?
Yeah, oh yeah. No, see, we knew that everything was properly identified. We knew when it was shipped, when it was made, who made it, and everything about it. We knew we had a complete history. So I dare say that if the records are still there in the lab right now, that you would be able to go back and pick up anything that we tested. Those records are still there. All of the reports we ever written, I suppose they're still there somewhere, or on microfilm or something, whatever they ever did with them.
Mm-hmm.
As I understand, the lab isn't what it used to be up there. They no longer heat treat anymore. Both our heat treat department is completely put. They don't do any heat treating to speak of at Oldsmobile.
You mean
now.
they're buying a
Everything.
material that already is
That's
heat
right.
treated?
It's already heat treated and processed, yeah.
You-
Probably now, like ring gears and pinions and everything, they're getting those, as far as I know, from Chevrolet or someplace else, and things like that. But our heat treating, Building 35 is completely out of business. The gear business in Plant 2 is completely gone, all closed up, scrapped out, sold, and everything is gone. So the heat treating business in Oldsmobile is non-existent right now.
When did that take place? After you retired,
Mhm.
obviously.
Just after I retired.
When you retired in 74.
Uh-huh, yeah.
Well, Gordon, had you planned to retire at that time, or
Well, somehow or other, I can tell you what it was. I got to be 62 years, and I'd been there 40 years, and I kind of run out of gas, and I went home one night and I told my wife I'm going to quit. And she says, "What do you want to do that for?" I says, "Well, I just tired. I'm not interested anymore." And it was the best thing I ever done. And at that time, they were just starting this program where they were asking for early retirement. So I retired at 62, and I'd been there 40 years with this ring here, and that's been about 15, 16, 17, 18, I don't know how long ago, 15 years ago.
Mm-hmm. And you really enjoyed your retirement.
Oh, that's the best thing I ever did.
Let me look through here to be sure that there's... here's a question. What was the most significant improvement that you remember? Either in a process or a type of engineering design, or...
That's a hard question. I don't believe I can give you an answer on that.
Okay.
I don't have anything significant that... I'm sure that quite a few things would be recommended by our department that we do, and we recommend that material changes or something would be done in certain parts because of certain reasons, and that be recommended to engineering, and if they liked it and agreed with it, well, it might have got taken care of. I don't recall anything that was real dramatic.
You don't remember any problems that you encountered that were difficult to overcome?
Oh, we had lots of problems, just tremendous problems.
Well, name a one or two.
Well, when we went into this emission thing, we got into one over in Plant 3. Every car had to have a tin can made with tubes in it that had a catalyst placed in it, and we had to form this tin can. It was like a tobacco can, but bigger, about this big. And this went in the trunk, and we had to silver solder these tubes that went into the can, and put those through a furnace to silver solder. But when we did that, the metal all come out black, and it would be scaly and everything on the inside. So we had to develop a process and a furnace that we could put those tin cans in one end, and they'd come out the other end of the same color, even brighter, just like a bright silver dollar. And so we had to design, and with the help of manufacturers and everything, a process where we could put make these tin cans.
That was part of the emission
That was the emission control, and
device.
every car had to have one. Every Oldsmobile had to have one. That was a pain in the neck, boy. That we had to have big gas generators. Oh, they were huge things, and they were making an exothermic gas. In other words, what this is you burn natural gas and air, but you control the proportion of the natural gas that goes in so it comes out, so it's an inert, non-explosive. And this we would force into the furnace so it would keep all the oxygen out of the furnace. It would burn inside the furnace. These cans would go through on a conveyor belt, maybe hundreds of them at a time, just going through very slow on a mesh belt and go through and come out the other side. And you could tell when your atmosphere was bad because the cans would come out discolored and they wouldn't be any good. And there wasn't anything, we were just making about a jump.
Well, you mean if they were discolored, they weren't they weren't serving
Our
the purpose?
atmosphere had gone wrong,
Yeah.
see, so
Well, why would they have to be bright?
because of the scale and everything, it would get on the inside of the can, everything would get all gooped up.
I
This
see.
is
Okay.
this is what you want to call an oxide. See, iron oxide that would form like rust. That's about what it was.
I
Only
see.
it would be black. See.
Mm-hmm.
But that was almost a 24-hour job for me for about a year, and then they finally got out of it. And we had a great big tank, probably as long as this house. It was just full of lead, and this tank, these cans, after they'd went through the furnace and been brightened up, they'd go through a tank full of lead, and they'd get coated with lead. And they'd come out, and that furnace, it was a great big pot. Oh, boy. We had burners on the side, and you just couldn't keep it running. Are you cold, Ellen?
No, I'm not, but I thought it might
No?
be cold
Oh, it's
out
getting
here.
cold out here.
Well, the heater might be open underneath there, I don't know,
Oh, that's down
but
there.
come inside and...
Oh, I think we're pretty near down
Well, I think
there.
pretty
I told
much.
you all I know.
Well, you certainly told us a lot. Well, let me ask you, Gordon, on this emission control device, how big a piece was that? You mentioned
You
it
know
was
what a
shape of-
Prince Albert
Yes,
tobacco
the
can?
flat.
Or this just an oversized Prince Albert can, probably about, I'd say 12 inches long, 6 inches wide, with a cap on the bottom and a cap on top, 2 holes and 3 pipes going down through it. Now we had to silver solder these pipes in there.
That's what I wanted to ask you
Yeah.
about. What is silver solder?
Well, it's a low melting solder. That's about all I can tell you. That it melts rather low, and it's quite easily to control. Only it requires a flux in order to adhere to the steel parts.
Now, what is a flux?
Well, a flux is kind of like an acid that etches the metal of the steel, and then it would the solder would stick onto it. And this was a big operation over in Plant 3. Rex Carter was the superintendent of that plant.
Would you like something to drink or a cup of coffee or something?
No, thank you, Evelyn. I just had lunch. Thank you anyway, dear.
Where are you staying around here?
The night's in out here.
What?
In fact, I'm going to ask you how to get back there, too. I haven't
Night's Inn.
checked in yet, but I will.
Is that on 301?
It's on,
Knight's Inn. Do you know where Knight's Inn is?
it's on exit 42 at the junction of 75 and SR 60.
Oh, that'd be back this way, wouldn't it? 60's back that way. 60 comes out of
Okay, I'll
Brady.
have to get some
You
instruction.
go right straight out of here and turn right. and
Where's
then-
your car?
I
She
parked it
parked
over
around
here.
there. Everybody thinks that's.
Mhm.
You go right straight out this street and go to the right. And
Well, when-
you'll find that's 301, and you get on to you'll connect with 75,